Okay, this is like a demonstration problem for the internal rate of return, and we've got all the same assumptions here. Our machine cost $80,000. It's going to return $15,000 a year for 10 years, and the required rate of return is 6%, which really doesn't matter so much for internal rate of return. If this was a hurdle rate, okay, if it had to be above that to be accepted, then that's sort of a different story. To do internal rate of return, you usually use the present value of an annuity table, which is what this one is here, okay? So I'll say present value of an annuity, because we've got the same amount that returns every year. If you don't have the same amount every year, then you've got to do this horrible trial and error thing to try to get it to work. So the key here is to set the present value of the inflows equal to the present value of the outflows, okay? Or vice versa. So present value out equals present value in. Now the present value of the outflow is $80,000, because that's $80,000. It's $80,000 today. That's what it's worth. The inflows are worth $15,000 a year times a rate, okay? Times our rate from the table. So I'll take 80,000 divided by 15,000 will give me my rate, and my rate is 5.333. 333, yeah. Okay? So then we go to the table, and we go to, this project lasts for 10 periods, so we go to 10, and you go across the table until you find 5.33, and you look at this and you think, drat, it is not here. Okay, which means you do interpolate, and I didn't think we would have to, but it looks like they're using it in the textbook, so it must be out there. So we've got, the rate is someplace between 12 and 14%, so maybe it's 13%. We'll have to take a look and see. So here are the present value factors for 12%, 5.650 and 5.650. Okay, there's 12% on both sides, and then the internal rate of return rate is 5.33. That's where we need to be. So there's 12%, and here's 14%. 14%, it's 5.216 right here. That's our rate. So if you take the difference between these two is 4.434, and the difference between the 12% and the IRR rate is 0.317. So we'll take 12% plus this ratio of 0.317 divided by 0.434 times the 2% spread, and that would give us 0.730 times 2%, because we're about 73% of the way through there, and our internal rate of return would be 13.46. Okay, we'll talk more about this later. Ugh. Okay, but I just wanted, the most important thing for you to get out of this is this piece right here. Okay, this is the key thing to really know. The present value out equals the present value in, and that will get you through IRR.